Welcome everyone to the 2025 IEEE Online Forum on Climate Change Technologies, and we thank everyone for participating. So, as a reminder, we encourage everyone to submit their questions in the comment and Zoom chat box. And today's third and final talk by Mercedes from Heriot-Watt University, and she'll be talking about accelerating industrial decarbonization through integration of whole system and place-based research and innovation. Professor Mercedes, the floor is yours. Please briefly introduce yourself and.
Thank you. Thanks very much. And thank you for the opportunity to present the work that we are doing on industrial decarbonization. What I'm going to do, I think we have an hour, so that includes Q&A. So I'm going to go through a number of slides and then happy to take questions at the end. I don't know how many of you, because I understand it's quite a diverse audience, you are familiar with the Industrial Decarbonization Research and Innovation Center. So I will mention a little bit in terms of the context and what we are set to do. And then I will focus on a series of examples that illustrate how critical it is to have whole systems, but also place-based innovation in terms of achieving industrial decarbonization goals. We are a UK center. The headquarters are in Scotland, in Heriot-Watt University, but we operate across a number of universities in the UK, and we also have over 25 international partners. Okay, so let me start first, just checking the time as well. Let me start with the characteristics of the energy transition. I think this is important because it really sets the context in terms of what we are doing here. So the first thing is that the energy transition has to be universal. And what we mean by that is that it has to get all emissions, but also very important as well, it has to go across a number of sectors as you have in there. And within that, if you look in terms of the emitters of carbon dioxide, but also other greenhouse gases like methane, you can see that industry is actually one of the largest emitters. So that's really important that we reflect on that. Now, the other thing or the other characteristic I want to focus on is that this energy transition is front-loaded. And what I mean by front-loaded is that although we talk about what is going to happen in 2050 goals, 2030, 2035 goals, a lot of the things that we need to make happen, particularly around infrastructure, have to happen in this decade. So it is front-loaded in that respect. And the third characteristic that I like to reflect on in my presentations is that it's rich in opportunity. So yes, we are talking about a lot of infrastructure. Yes, we are talking about massive investments. But fundamentally, what the energy transition allows us is to actually develop new products, new processes, new support services as well. And this is really what is critical in terms of how we view the energy transition. So please kind of keep in mind those three characteristics: universal, front-loading, and opportunity. Just moving. Yes. Now, when we then zoom in into industrial decarbonization in terms of how we can decrease the emissions from the industrial sector, there are a series of characteristics as well that we need to keep in mind. And you have them in there. And the first one has to do with economic. There are cost implications. In some cases, we have assets that we are running for a number of years, and also that we want to remain competitive as we go through the transition. Another important aspect is the social. There are jobs. It's going to be a disruption of jobs, and that means some jobs are going to be lost, some new jobs are going to be created. And also we need to make sure that we understand the impact of the community as well as equity concerns. And I'm sure many of you are familiar with the term a just transition. From a point of view of technology, we need to consider not only that we need to deploy a number of technologies, but we need to scale them up, and we need to integrate them into existing industrial practices. And sometimes it's the integration actually what may make a challenge rather than the technology as such. And then the other element or the other point as well is the lock-in element. Sometimes we feel like if we take decisions on a particular technology and we start deploying it, what that means is that we are locking options going forward. Supply chains are indeed very important because we need to consider things like critical minerals, geopolitical opportunities or constraints, and also where these resources may create additional trade tensions. And we know, for instance, in the case of the CBAM, the Carbon Border Adjustment Mechanism, that is meant to protect industries as they decarbonize, but also can create conflicts in terms of the transfer of materials through borders. And then, finally, there are a series of systemic or unintended consequences. And this actually come from how different technologies will come together. And maybe in some cases, if you are focusing on a particular technology, that may actually have an impact on how other sectors or other technologies may be deployed as part of a systems approach. Now, if we focus these challenges now in terms of the energy-intensive industries, you have a map there. Depending how you look at this, but really you are looking somewhere between 30 to up to 40% of the emissions globally come from these energy-intensive sectors, so the manufacturing sector industries. Now, that distribution obviously changes on location and geographies, and also what is the manufacturing sector that is predominant varies as well. So if I take as an example China, what you can see there is non-metallic minerals, cement, and iron and steel are predominant over chemicals. If you look in terms of Europe, there is nearly the same distribution. If you go to the US, the predominance is on chemicals over non-metallic or metallic manufacturing sectors. But regardless of where you are, there are a series of challenges for all these energy-intensive industries to actually transfer or to move to energy transition. And those challenges that you have in there are the emissions come from the process. So in other words, even if you were to use completely renewables, you will still have emissions coming from the process itself. You also have challenges related to this process being already highly integrated. In many cases, they operate at high temperature. And as you probably know, when we talk about high temperature here, we are really thinking 800, 900 over 1,000 degrees C. Then there are existing plant lifetimes. They are operating for a number of years, and these assets are likely to stay for at least a couple of decades more. And then the last two challenges there have to do with the materials that they are produced. Generally, not always, but generally they are going to be low-cost commodity products in a number of these ones. And also we are going to be looking in terms of a global competition, or in other words, global competitive markets. And what this means is that we may have carbon leakage, or you are importing a product from potentially a country with a lower environmental credentials. And in some cases, like in the case of steel, we know steel travels far and wide. You may have cement that doesn't travel as far, and then chemicals generally depends on the type of chemical, but they do tend to travel and be exported. So now, looking and in the context, I'm going to focus a bit more of the UK. What we have is a net zero target. If you look at the map on the graph on the left-hand side, you can see that those emissions are decreasing. If we go back to 1990 to 2025. So all this is a good signal in terms of those emissions going down over time. Now, particularly, they have been going down for power generation, but we have other sectors where actually those emissions have not decreased. If we look, for instance, at aviation, or if we look in terms of agriculture, and industry, what is the blue line in there, is actually quite interesting, because when you look at that, the first message is that the emissions from industry are decreasing. However, the main reason why those emissions have decreased in the last 20, 30 years is because we have de-industrialized. In other words, quite a lot of our manufacturing sector, we have closed it down, and we are importing from other countries. Clearly, this is not something we want to continue doing. We want to keep our industry, we want to reindustrialize, and we want to decarbonize. And the graph that you have on the right-hand side is one key message I want you to take with. Each of the colors is a different technology. And as you can see, there are a number of colors. Electrification is picking up a lot of interest within the UK and a number of other countries. But regardless of what technology or what sector, the message here is that we need a portfolio of technologies. There is not one single technology that is going to be able to decrease all the emissions. And that's something to keep in mind as we develop and deploy technologies at the scale. Now, the UK was the first country that in 2021 actually deployed an industrial decarbonization strategy. As you have in there, we are actually in the process of reviewing that strategy, and that strategy will be published in 2026. Now, what I want you to look in there is when you look at the map, starting from 2021, net zero emissions by 2050, the initial steps that we are doing in the 2020s, early 2020s, is on decarbonizing clusters. And clusters are areas where we have a very high concentration of different manufacturing industries that are co-located within a geography. So the first industries to decarbonize in the UK will be clusters, but we will be decarbonizing every industry in clusters or in dispersed sites. Now, on the back of this strategy on 2021, the Industrial Decarbonization Challenge was launched with focus, as you can see in the map in the middle, on the industrial clusters, and is really looking at around 10% of the UK GDP comes from industry, around 3 million jobs, but also around 15%, 16% of UK emissions. The opportunity here is to keep the industry, to keep growing, but also create new jobs, create green jobs as we decarbonize these sectors. The overall program from the government, as you have in there, is in the order of £500 million that comes equally between government and private sector. So 210 million come from a government match with 260 from a private sector. And the goal here is to develop 4 low carbon clusters by 2030, and then from there moving to the world's first net zero cluster by 2040. And as you can see on the map in the middle, each of these different colors is a different sector, whether it's cement, chemicals, food and drink. And again, what you can see is that the clusters encompass a number of sectors. And that's really important because then when you decarbonize a cluster, you actually decarbonize a number of industrial sectors, not just one. Now, the Industrial Decarbonization Challenge, it had 3 elements to the program. It had what is called the cluster plan projects, the deployment projects, and IDRIC, the Industrial Decarbonization Research and Innovation Center. And I'm not going to go into detail there, but you can see the number of projects, technologies, the different clusters, so all the way from industrial carbon capture to onshore, offshore operations, industrial infrastructure, as well as building flexibility in the fuel demand of the different clusters. So all this portfolio of technologies and all this portfolio of projects, it became the Industrial Decarbonization Challenge. On the coming slides, what I'm going to be doing is focusing on IDRIC, the Industrial Decarbonization Research and Innovation Center. That's the part of the program that I'm director, and I'm going to give you a series of examples of how we take a whole systems, place-based innovation approach to decarbonize industry. And yes, the first element to keep in mind in terms of industry and IDRIC is really how we look at, as I said before, we want to accelerate the energy transition, but also we want to do it in a way that we keep competitiveness and productivity, as you have in there. So our logo, as you have in the middle, is that we realize these green industrial futures. Research and innovation is at the heart of what we do through a whole systems. So we acknowledge from earlier on that technology alone is not going to do it. You need to have technology, but you also need to have policy, business models, and the regulatory framework. And all that together makes a solution brought to market. But that doesn't need to happen alone, and it should not happen alone. Alongside that, you need to make sure that you have an element of policy, that you actually help to develop and support effective policies and regulatory frameworks. And if you look on the right-hand side of my slide, it is also critical that we have skills and leadership. And alongside that, we need to exchange knowledge and lessons learned and best practices. This is really important because as we have learned over the last 3 or 4 years, industrial decarbonization has picked up a lot of interest and a lot of momentum really in a number of countries. So it's important that we do things as what we are doing today, where we exchange knowledge across industrial decarbonization. And this is a report that I co-authored a chapter here. It was published by the Climate Club. We published it in COP30 a couple of weeks ago. But really what we are looking is around the principles of this whole systems approach to decarbonize industry, as you have in there. And what you can see is in terms of the technologies, we need to integrate them, but we also need to consider environment through, in many cases, environmental life cycle analysis, social inclusion, as I mentioned before, the element of a just transition. And in addition to that, we need to make sure that we have these economic frameworks and policy frameworks. And there is a chapter that I author in this report where I look at those characteristics and also how, from the point of view of policy, you can incentivize the development of a whole systems approach to decarbonize industry. Now, and this whole systems approach, as you have there, is actually considers not only the technology, but also, as I said before, those environmental skills, socioeconomic. And then if you look on the bottom, then is the policy regulations. And very, very important is that systems and scale up. Because in some cases, you may have the technology, but it's a matter of integration and scaling up. But to do that successfully, you need to think about this whole systems approach. And the map on the left-hand side that you have there is a series of clusters that we work with. And over the years, we have been increasing the number of clusters. But as you can see, they are spread all over the UK, all the way from clusters that are maybe more focused on, in some cases, steel or petrochemicals, to clusters that have quite a wide range of sectors within that geography. Now, let's start looking a little bit more about technologies. So when we look at technologies, as you have in there are a number of them, and surprisingly, from what we have already discussed, we group them in general as those 5 buckets, if you may: improving energy and resource efficiency, electrification of processes, switching to low carbon fuels that may be hydrogen or maybe other low carbon fuel. And then for the cases as well where we are still producing CO2, we need to make sure that we capture it. And that's that capturing the CO2 emissions and storing them, or utilization of the CO2 capture. And then also we look at technologies that have to do with what we call greenhouse gas removal. In some cases, it's also known as carbon dioxide removal, CDR, or negative emission technologies. And we need a portfolio of all of those technologies to be able to meet the UK target of net zero by 2050. But even more important than that is that within the next 10 years, by 2035, emissions from industry will have to go down by 2/3 of our current emissions if we are set to meet 2050 targets. Remember what I mentioned at the beginning is front-loaded. This is another example what it means by front-loaded. Unless we meet 2035 targets, it's going to be very difficult to meet subsequent targets after that. Now, within the technologies, there is a number of different technologies, as we already have discussed. But then what we need to consider is the dependence on these technologies, whether they are mature, the sector that they may be addressing as well, and a regional dependence. So if I was to pick, for instance, cement that you have on the top line in there on the left-hand side, CCS is going to be critical because 50% of the emissions from a cement sector, they actually come from the process itself. And if you look at the map on the right-hand side, again, it's a map with the clusters, but what you can see is a portfolio of technologies, and those technologies have a regional dependence. Why? Because if you are in, let's say, this cluster here, on the South Wales cluster, you actually have not that much opportunity, that many opportunities in terms of storing CO2. While if you are in the Humber, Teesside region around here, you have a lot of opportunities to store CO2 just basically outside your front door. So that what means is technologies have maturity, sector, and regional dependence. And you need to consider those 3 before you start identifying options suitable to be deployed. And we talk about technology readiness levels. I'm sure many of you are familiar with that. And the technology certainty level, but also what is becoming more and more important nowadays is that we understand market readiness level. And that market readiness level, it has to do with the research and development phase of the technology, but also needs to be in terms of what technologies have entered the market, they are ready to be deployed, and actually it's about the scaling up and that technology adoption. And this is a framework that is being used by the Government Office for Science in the UK, where it's not only TRLs, but also TCLs and TMRLs, and how you need to combine all that to really start identifying the best or the most suitable technology. As part of the IDRIC, the Industrial Decarbonisation Research and Innovation Centre, as you have in there, we have funded 100 projects within the last 4.5, 5 years, with 46 different research institutions and with over 240 delivery partners. Now, what we mean by these co-delivery partners are industry, in some cases are policymakers, in some cases could be trade organizations, is the users of that research that we co-produce. And there are a series of outcomes as a result of our approach, not only in terms of the funding that we have raised, but also in terms of the prototypes, skills, workforce, but also something that we are very proud of in terms of being able to increase or be able to facilitate effective policy formulation through, as you can see on the top right-hand side, 42 policy recommendations, as well as a number of policy events that we have run over the years. And then very important on the bottom right-hand side is our impact is not just within the clusters, but it's also outside the clusters and outside the UK. And as you can see in there, we are engaging currently with over 25 countries that are also looking at the whole systems approach to decarbonize industry. I'm not going to go into detail over the 100 projects that we have delivered, but I do encourage you to have a look at our Knowledge Hub. You go to our Knowledge Hub, you have the link there, and actually you can search by sector, you can search by technology, you can search by cluster. And it's not only papers, it's not only journals, but we also have reports, webinars, white papers. So it's really a wide range of content and knowledge that you can gain by just visiting our Knowledge Hub. So I strongly encourage you to visit it. And in addition to lots of outputs from those 100 projects, this year in 2025, we also have published what we call frontier reports. These frontier reports bring together a number of different findings across a number of projects that we have funded, and we synthesize them in terms of where we have advanced the state of the art, as well as a series of recommendations of what's next for industry, for policymakers in terms of supporting a sustainable transition to net zero. And as you can see in there, they go from technology focus, like carbon capture, all the way to different tools like life cycle assessment, or as well, I would like to highlight even reports that we have published on green finance or systems planning. So a wide range of topics, again, all really available in our website. What I would like to do now in the time that I have, I want to focus on some specific findings that I think bring together a little bit the flavor of how we approach decarbonization of industry through, again, a whole systems that is also place-based when it comes to research and innovation. So one of the things that we have is looking at an assessment framework. From what we have been discussing so far is not only a number of technologies, but also you need to understand how a technology may be deployed in a particular location or for a particular cluster. So then what we have in here is looking at a framework that will integrate all the way from the potential stakeholders to the communities to actually make sure that you have the data and you can evaluate the process. So it's really a holistic approach. And the way we are doing it is that through a series of engagement with the local communities as well as with the industrial stakeholders. And we put that up front at the very beginning And as you can see, this is an iterative process that is going to actually cycle till you actually find, what if you allow me to say, never the perfect solution, because sometimes perfection is in the middle of doing good things. So we are not aiming for perfect solutions. We are aiming for the best solution that we can identify at the time when industry need it most. And that's really what this framework allows us to identify. Now, the previous framework was looking in terms of how you engage community, how you engage different stakeholders, but also what we have been doing here, and this is an example, is systems analysis. Again, different maps of the UK where we have looked at different scenarios, whether by 2035 we enhance electrification, or other scenarios where we enhance hydrogen. And within each of those different scenarios, what we are looking is what are going to be the optimal solutions that you're going to find for a specific cluster. The reason why we want to do this is because what we found is that although a number of frameworks do exist, actually there is quite a lot of fragmentation of these frameworks. In many cases, you have a framework for a technology, but there's not a technology not a framework, apologies, that allows you to integrate different technologies. So this is what we did with this. And we also did it from a point of view of a geographical approach. So as you can see there, we have, within the UK, we have gone to a level of granularity where actually we can see what will be enhanced electrification or enhanced hydrogen, different scenarios, and what will be the impact with different geographies, different locations, in terms of which pathway you may be able to approach. What that allows you is to identify for your particular sector, industry, or cluster or geography, what are going to be the preferred options in your pathway to decarbonize. And what this allows as well, I'm not going to have time to go into that detail today, but what this allows is actually start unpacking from a point of view of permitting, planning, infrastructure, what will be the key areas where we need to start focusing earlier on to make sure that we have the infrastructure that we need and that is ready to actually get some of these large projects to take place. Now, we know about the importance of CO2 to capture it, to transport, to store it. So what we have done is a series of projects where we have been looking at capture of CO2. I'm not going to go into detail on that today. Again, you can visit our website and you will have a number of outputs on CO2 capture technologies. But what we have done here is actually combine different frameworks that allow us to optimize and to forecast on a multi-temporal scale what are the areas and the clusters that actually are best suited for storage of CO2 at certain times through the pathway to decarbonize. Now, the way we have been doing this is looking at regional and cluster case studies, and that's what you have in the map. So if you see my pointer is all the way from Scotland, or Grangemouth as we call it here, Grangemouth is in there, to the Teesside Humber cluster, to the Solent cluster, South Wales, Black Country, and then the Northwest. This is the area around Manchester, Liverpool, the Merseyside. So what we do is looking in terms of where are the opportunities. Oops, I just gonna move back, sorry. We look at the opportunities and the frameworks that will really allow us to do a forecast of how we can optimize the storage of CO2 across all the different options that we have in the UK. Now, when we do this, the other area as well that we work on is that the CO2 will have to be transported, in some cases from one cluster to another. And what we look as well is what are the opportunities to transport CO2, whether it's going to be pipeline, whether it's going to be shipping. And as soon as you start talking about transporting a gas, then you need to make sure that you are able to meter that gas for fiscal purposes as well. And you will need to understand if different impurities get into the network, what will be the effect of those impurities in your metering for, again, fiscal purposes. We also have been looking at technologies, how we can help to the risk in the case of BECCS. So this will be about bioenergy with carbon capture and storage. And as I'm sure many of you know in the room, there is always a question about what is the type of biomass that you can use to actually make sure that you have a sustainable bioenergy. And of course, it goes nearly without saying, not competing with food when we're talking about bioenergy. So what we did is a series of studies in one of our projects where they were looking at different feedstocks for bioenergy, and then we're able to match that in terms of what will be the supply, the demand, and then how you will match that with opportunities for carbon capture and storage. Again, as you can see, what we do here is not talking just in general terms of where this is going to happen, but we look at the places where this biomass is being grown, the purposes for which it's being grown, and how actually that could be then a suitable feedstock for BECCS. And in some cases, what we have identified as well is that some of these feedstocks will not be suitable for BECCS because of the availability of supply, or maybe because of where they are located with respect to where we need this energy to actually be produced and used for industrial clusters. Now, a very important element is actually when we look around the just transition I mentioned before, the energy transition for that to happen, we need to ensure that also takes social considerations into place. So what we have, again, through different frameworks that we have developed, we have integrated, and all these frameworks, of course, are going to be data-driven. But what we have been looking is in terms of what it means for all these different clusters. Again, the clusters that we have focused, you have them in there, the Scotland, Northeast, Yorkshire, but all these different clusters that we have in there, what it means this transition in terms of a gross value added. So what will the local communities see as the industry that they're supporting, that they get their jobs, that actually transition to net zero. So we did a study, again, quite extensive, where we look at the GVAs and we identify that and we unpack that in terms of job creation as well. And you will see that in the coming slides. Now, one area that we keep as well asking questions is around these projects, this infrastructure that are very large projects. So the question tends to come very often as well as what happens with the financing of these projects. And I do want to highlight that there is a significant difference between funding a project, where generally you're going to be expecting there's going to be a significant portion of that coming from the government. You may need to do some match co-financing. But this is purely looking in terms, we move away from funding projects into what we really need, and this is financing the projects. In other words, there are finance mechanisms by which industries can take a decision to go or not go ahead, but they will do that to a big extent independent of subsidies or independent of funding money. And what we did is through colleagues from business schools in the UK and in other parts as well, they look at one of those mechanisms, and that was actually the green finance, green bonds. Again, this is all you can find online, and it's an extensive Frontiers report we have also on green finance. But really what we were looking here is that right now, within the context of Europe, we actually have a significant shortfall of the investment that we need to actually realize this transition, this energy transition. I do want to say as well, when you look in terms of the volume of green bonds, they have gone significantly. If you look at 2014 to where we are now in 2013, obviously there was a bit of a dip here because of COVID, and then the market took a bit of time to pick up again. But the market is going up, and what you can see now is we have in the order of around $600 billion that are actually on green bonds. Different countries are playing at different levels, but this is a market that is increasing. However, it is a market as well that is not picked up all the interest that we need in terms of green bonds for financing the energy transition. And what we have, and that's the bottom part here of the slide, one of the reasons, not the only reasons, but you will read in one of our reports. And one of the reasons and the challenges here when we talk about green finance is because generally what we do not have is a consistent taxonomy of what green bonds mean. And that consistent taxonomy in some cases is because doesn't even exist one, or in other cases is when you compare taxonomies across different countries or different regions of the world, they mean different things in terms of what they include. And that creates challenges when we are operating on a global energy transition, and we need to have global finance in place to make sure that we get the financial assets that we need. Again, all this is well documented into one of our Frontiers reports. Now, I've been mentioning a few times on that policy and social dimensions. And I think here the point I want to highlight is that I'm sure you are all familiar with having a technological license to operate. In other words, you need to have your technology certified. It has to comply with a series of tests. It has to comply with maybe with some ISO or other standards. But sometimes what we forget is that we also need a social license to operate. And in fact, if you don't have a social license to operate and you only have your technical license to operate, what you may encounter, particularly when we talk about projects at this scale, is that you may not be able to reach the market. So I think it's really, really important that we remember that technology license to operate does not give you the social license. Now, what we have developed here with colleagues, expert in the just transition, again, in a number of universities across the UK, they have helped us to develop a framework freely available on our website that guides you through the steps of how to ensure that you have a social license to operate. And one of the things that I want to highlight of this SLO, as we call it, social license to operate, is that they have to be place sensitive. In other words, the same as we talked before, that technologies are place and region sensitive, your SLO will also be place sensitive. And it's very important that you have that in mind when you start putting all that community engagement together. There are also policy impacts as well and policy dimensions, and we have published quite extensively in terms of what are a series of policy frameworks that actually are more likely to help you in the transition of your industry. Now, I have mentioned a few times the skills and the workforce. And this is work, again, that we did back. We published part of this report in 2022, so just about 3 years ago now. And what we're looking is what it means in terms of jobs for industry in the UK to transition. So the way we did this is we actually relate projects that have to happen across the industry to decarbonize. We link that to the CapEx that was needed for these projects, and then we link that to jobs. And what we came up with is that we will be looking in the order of over 350,000 jobs to be able to deliver industrial decarbonization. And that was alongside £515 billion. And we didn't just give a number, because when you look at reports, many times they give you a very high level number. Again, look at our report, and what we did is we went into how we unpack that on pre-construction, construction, operation, skills development. And we're able to provide granularity across all the different sectors that we need to be engaging here. And then we also look at this not only from the total numbers, but also at the region level. So we look at the clusters and also other sectors outside of clusters. Again, the headline is the same, it's over 350,000 jobs. But also we actually unpack them on a number of different geographical locations. And we also unpack them on what we mean in terms of job years demand. We launched this, as I said, just 3 years ago. And when we launched this in London, this report, we have members from Department of Education, large employers, we have unions as well with us. And one of the key messages I took from that launch event of this report is that in the energy transition, actually, we are going to be running out of skills before we run out of anything else. We are not going to be running out of technologies or innovation or even access to funds. It's probably going to be skills, the one that we may run out first. So because of that, we have been working quite extensively in terms of how we engage communities, all the way from local schools, primary schools, high schools, in the opportunities of the energy transition. We've done this through a visualization tool, again, all freely available. I think we have on the order of 3,000 to 4,000 users now, a number of schools as well. And when you go into this visualization tool, actually you can enter as a student, you can enter as a researcher, as a teacher, as a policymaker, and it shows you how important industry is actually to support jobs and the opportunities. Let me see if the video works. Yes. And then what you will be able is then to see a series of videos of how different jobs are available, what it means that, I don't know, availability of hydrogen, what it means when I travel, what it means when I buy my groceries, and how all this is related to job opportunities. Through the different areas that you may pick and select as you go across, there are videos. We have close to actually 50 videos that illustrate a range of opportunities, not just university, I have to say, but a range of opportunities to engage in what we call these green future landscapes, and hopefully to inspire generations, the younger generations, to join us. And because of this as well, an opportunity to train as well at the different stages of education, but also at the PhD level. October last year, 2024, we launched a center for doctoral training where we are training 100 PhD students, 5 cohorts of 20 students on this whole systems approach. So we take them through technology, we take them through policy, we take them through business models, social license to operate, and we have a number of industrial partners as well that are supporting this PhD program. If you're interested, we are just now doing the recruitment for cohort number 3, and there are also opportunities for these students to visit other universities outside of the UK and outside of Europe. Just looking at the time, okay. Now, a couple of other points I want to mention, wrapping up. Some of you may be thinking that a lot of my presentation was focused in the UK, and you're absolutely right. And that's because that's where we started the program. And as I said, we have a number of international partners as well. However, and this is a word from the World Economic Forum, WF, clusters are not unique to UK. In fact, if you look globally, they have identified there are more than 10,000 industrial clusters. So this happened, and that map only points some of them. There are many other in regions actually that are not identifying that map. But what that map tells us is if you take just a small number of those ones, 100 of those clusters out of 10,000 that are available, if you focus on those 100, what you will be able to do is to take 5% of the global CO2 emissions and as much as 15% of the global CO2 emissions from industry. And this is really one of the beauties of the cluster approach. By going after a handful of regions, you have a significant impact because infrastructure is in place. In many cases, skills are available, or you can retrain the existing workforce. And that gives you a huge leap start in decarbonizing other industrial sectors. Because of that, we have had an increasing interest on actually international delivery, all the way back to 2023, where we start running international workshops. We also work in a series of reports with a number of international partners. And this is also something that we are very, very keen to continue delivering going forward. So if you're interested in working with us, it doesn't matter which part of the world you are, we'll be very keen on listening and exchanging knowledge around industrial decarbonization. And then to conclude, there are 2 key tools that I think I have been mentioning here and there through my presentation, but I just want to make sure I reinforce the message. And those 2 tools that we absolutely must have are innovation and collaboration. If you look on the map, on the graph, I should say on the left-hand side there, what you have is the role of innovation. And what we have is emissions, we have technologies, and yes, those numbers vary. This is published by the International Energy Agency. But fundamentally, the point here is that somewhere maybe 30, maybe even as much as 50% of the global emissions as of today, they don't have a technology mature enough to be deployed at scale. And I want to place my emphasis on mature enough because this does not mean that the technology doesn't exist. What this is telling us is not mature enough. So we still have to do a bit more of research, a bit more of innovation to get it there. Now, this would be no excuse to don't get things done. This would be no excuse to stop us from doing good things. Because the other side of the coin is that for more than 50% of our emissions, we have technologies today ready to be deployed at scale, and we need to get going with those ones. And on the right-hand side is the role of collaboration. Now, if you look at the kind of the gray line, what it's telling us is that if we don't work together, and this is a stark message, it's going to be delaying our goals of net zero by as much as 40 years. And we do not have the luxury of being 40 years late in something as critical as it is to humanity to reach net zero in a sustainable way. So this brings me to my concluding remarks. Decarbonization industry is critical to meet net zero targets at the same time as we provide growth for society and for our economies. A whole systems approach is critical that we do it because it's only through a whole systems approach that actually we are able to really integrate all the different aspects. It's not just engineering, but it's also environmental, it's economic, social, policy, regulatory frameworks. And as I said at the beginning, this is about opportunities. It's opportunities for new technologies, processes, services, jobs, materials, and how we can do this together. So that was all I wanted to present. I think that was pretty much the 45, 50 minutes that you asked me to present. So again, many thanks for the opportunity to present. I appreciate it. And I hope that there were some messages here that resonated with the audience. Very happy to answer any questions. And again, thanks for the opportunity.
Well, thank you, Mercedes. Dylan, why don't you take the questions?
Yes. Thank you, Professor Mercedes, for the interesting and the much needed talk in the context of climate change. And we have some questions in the chat box, and I'll read it for you.
Okay.
So the first question from Charlie, his question is, what is your favorite technology to pursue? On the other hand, what technology might have the biggest impact?
So that's a really good question. I get that question before, and if you don't mind, I'm going to give the same answer I gave other times. And my answer to that is a little bit like when they ask me which one is my favorite child. I love them all. They are all different, and they all have, they're good and the bad things some days. And I think this is really what we need to reflect here. I do have some technologies. If I look at a particular sector, industry, geographical location, I can tell you this is probably the best technology to deploy. But that's because it's a technology for a particular solution to market. But we need CCS, we need hydrogen, we need electrification, we need resource efficiency, we need energy efficiency. And depending on where you are is what technology you will be choosing. And I do think that there are a number of things that we can do nowadays, particularly about energy and resource efficiency that we can do right now, and we shouldn't delay that. But then there are also critical technologies around CCS and hydrogen. And without them, it's going to be very difficult to reach net zero targets. Again, I mentioned at the beginning, in some cases, emissions are the process. So it doesn't matter whether we have only renewables, we will still be emitting CO2.
Thank you for that. We have a very interesting next question from Ron. And he asked, I see many criteria being examined. Considering that we are engineers, I do not see evidence of thermodynamic analysis. Investment in thermodynamically inferior systems is not warranted so thermodynamics need to be precedent for investment.
Mm-hmm.
So who does this work and has policy tools to inform non-technical decision makers?
So we do have projects actually that they have focused on thermodynamic aspects. So it's true I did not present them here, but I do encourage you to go to our web of knowledge. And actually you will find some of those projects more on the engineering principles of thermodynamics, for instance. all those things are what we bring under an engineering approach. And then within that engineering approach, then we bring all the other elements to be able to do policy recommendations. In what we have seen over many years working in this space, technology tends to run ahead of policy, ahead of business models, ahead of regulatory frameworks. So what we need to make sure is that we continue developing the engineering technologies that we need, absolutely based on the first fundamental principles of engineering, but that alone is not going to make it to market. A technology is only a solution to market when you have a whole systems approach. One thing I can think of as well is specifically, we have been looking at some thermodynamics when it comes around different gas mixtures as well for transport. And also we've been looking at thermodynamic aspects of different CO2 capture technologies as well. So yes, I'll be happy. I don't know who asked the question, but I'll be happy also to correspond directly on those specific projects.
Oh, thank you. I do have a question for myself. So in terms of this low carbon technologies such as hydrogen generation storage, biofuels, or wind energy, so what do you think the optimal production, storage, or distribution pathways to meet the industrial energy demands? Have the technologies are matured enough to see that will they be adopted in near future by the industry?
So when it comes to hydrogen, and just please tell me if I think this is what you were asking. What we are facing when it comes to hydrogen, and we talk to our industrial stakeholders, is a little bit, if you allow me the expression, of a chicken and egg situation, because there are some hydrogen producers that they say we can produce hydrogen as far as you can guarantee the off-takers of hydrogen. And the off-takers or potential off-takers of hydrogen say, well, I'm not going to be transitioning my boilers or my furnaces to hydrogen if I cannot ensure I'm going to have that supply of hydrogen at a price that is competitive with the existing prices that I'm paying now. And then let's not forget that you also need to move the hydrogen in some cases from the production to the off-takers. So one of the things that the UK government is doing to try to unpack a little bit this chicken and egg is creating a series of business models that then industries can buy into to actually make sure that there will be those off-takers as well as those providers of hydrogen. Now, one of those models is actually, and you may be familiar with contracts for difference. So contracts for difference have been very successful in renewables to guarantee a price of the electricity, and then you sign a contract on basis of that price. If the price was lower, then you were covered that gap. If the price was higher, then you actually were generating additional revenue. Now, when you try to get a model like a contract for difference for CO2 or hydrogen, there are some challenges there because there is no price of CO2 that actually can guarantee nowadays a CO2 market, free market, and equally there is no standard price of hydrogen. So then what you need to do through a policy of business models is guarantee the strike price or the market price of hydrogen, or have a minimum floor price of CO2 to be able to successfully have contracts for difference that will allow the development and maturing of these technologies.
Thanks for that. So I have one more general question. Since you're from Scotland, does tourism industry significantly contributes for carbon emissions, or is there any strong data available?
So that's a really good question, and I don't know exactly how much the tourism. Obviously, when it comes to tourism, a big contributor is aviation sector. And the aviation is actually, we have published some work within my own research team on sustainable aviation fuels, because some of this hydrogen that could be produced then actually could be used also for synthetic aviation fuels. Now, we have early stages projects looking at sustainable aviation fuels as a contributor or as a way to decrease the emissions. Aviation is probably one of the hardest sectors to decarbonize, particularly when you are looking to long-haul flights, because for short haul flights, there may be opportunities around batteries. there may even be opportunities possibly on hydrogen. But when you go into medium to long haul flights, then it's only sustainable aviation fuels. Right now, the worldwide production of sustainable aviation fuels is less than 0.1% what we need to reach our targets. So we need massive scale up of biorefineries, of SAF, of the whole infrastructure, because right now it's very, very small production. Again, we have a paper we published, and one of the concepts that we have formulated as well is around green flight paths. Some of you, if you are familiar with decarbonizing a maritime transport, you may be familiar with the Clydebank Declaration that happened in COP in Glasgow a few years ago. So we have taken a similar model, but we have developed that concept for the aviation sector, and we have identified what flight paths actually will be the ones that you need to start decarbonizing because of the type of fuels, the type of passengers, the cost of the flight, and those will actually start stimulating the production of SAF at the scale. But that, as I said, is a massive, massive challenge that we have, not only Scotland, many other places where tourism is critical for their economies.
All right, thanks for that. We'll take one more question from the attendee. I think Azuka asked the shift from invention to implementation. What experience and advice can you share with us?
Yes, so I think that's a really good question, because we talk about innovation, and then is that implementation that is what really needs to happen, right? So I think that was the question, right? The difference between innovation and implementation.
Yes. That's
okay. Just when I'm okay. And here it really comes a little bit. Sorry, here it comes a little bit the point I was trying to make as well around the difference between funding to financing. So we have models, business models that actually they may be good for funding and in some cases for financing, but what we have is a disconnect to transition from one to the other. And I don't know, maybe some of you are thinking of the valleys of death when you go through TRLs for technology. For me, it's even more fundamental than that. There is a disconnect between funding and financing. And that's why we see a disconnect between innovation and then what happens at implementation. And unless we fix that pipeline, so there is a continuum of different models that can take you from funding to financing, the implementation gap is going to be always bigger than the innovation gap that we have. And that goes back to what I was saying, one of my last plots from the International Energy Agency, IEA, that we do have a number of technologies that we could deploy today, but we are not deploying them at the scale or at the pace that we need, because it's that gap between funding and financing.
Oh, the IEA you refer to the impact acceleration account. That one.
Yeah.
Oh. Okay, so we have time for one more question. I think that's from Charlie. What criteria do you look at for what I'm used to calling technology readiness level, TRL? So what criteria?
So I'm sure everybody in the room, or particularly a colleague who asked the question, is familiar with TRLs. We try to stay away to some extent to TRLs, and let me unpack a little bit more that. Some of those 100 projects, they actually have been conducting tests at demo and pilot facilities. At which point, they're operating on a pilot or a demo facility, but it was some fundamental knowledge that they were generating. So sometimes it's not straightforward to say what TRL I'm operating at. But also, and this is why we try to, in some cases, stay away, or in many cases from TRLs, is because for colleagues here in the presentation today who are heavily involved in going from that innovation to implementation, they know that progression through TRLs is not linear. Sometimes you think that you are at a certain TRL and then things don't work and you have to step back. And sometimes you have a breakthrough and actually you can nearly leapfrog quite quickly through a number of TRLs. So for us, rather than definition of TRLs, is really working with industry to understand what is the challenge that they have. Every one of our 100 projects is addressing an industry challenge. And as I say, in some cases could be testing at the pilot facility. In other cases, was actually a piece of software that they need to actually test and develop. And that's really where we are moving. What is the industry challenge that needs to be addressed?
Oh, that's nice. Okay. So I think with that, I think we have come to the end of this discussion. And thanks again, Professor Mercedes, for the wonderful talk and very productive discussion with you. And thanks for joining us today.
Thank you. Thanks very much. Thank you.
Thank
Bye.
you. Bye. So with this, we have come to an end of all the sessions today. And if any announcement is there for the day, Charlie?
No announcements for today. Hope you can join us tomorrow and on Thursday.
All right. Okay. Thank you, everyone, and have a good day ahead.